Hey guys, welcome to this video on Python and machine learning, where we're going to create a Python program that predicts the price of houses in Boston using a machine learning algorithm called linear regression. And I'm on Google's website called colab.research.google.com. And the reason why I'm on this website is because it allows us to easily get started with Python. So you don't need to download Python on your computer. You could just run it from your browser. All you need, of course, is a browser and a Google account. So I will be sure to put a link to this URL in the description below. Okay, so you guys can also get on this website and start programming immediately in Python. All right, so first thing we're going to do before we write the program is kind of get used to how to maneuver on this site a little bit to get started with programming. So first thing we're going to do is click on File, and then we're going to click New Python 3 Notebook. All right, and that's going to open up a new tab here. And then it's loading up right now. And so now we see something here, this little rectangle. It's a cell, and we can immediately start programming right away in Python, which is pretty awesome. So I'm just going to say print left parentheses quotation, quotation right parentheses, and we're going to print this is a Python program. And now to run this, all we have to do is click this little button over here. And what we're going to see is that it's going to print that statement to our screen. So we get this is a Python program. Now let's go ahead and get rid of it by clicking this X over here. All right. And let's do another print statement. So we can write a whole Python program here. So I'm going to say this is some more text. And also let's write a for loop maybe. So for I in range 2 to 5, we will print out I. Okay, now let's run this. And what we see is we get this is a Python program. This is some more text, and then we get 2, 3, and 4, just like we expect. Now, of course, this is what we call a Python notebook. So you'll notice that the name of my file is Untitled 5. Yours may be different. And then it has the extension .ipynb. All right. So Python notebooks are pretty cool because they allow us to kind of break up our code and run them cell by cell individually, which is pretty awesome. So let's clear this here, and let's take this and right click. Actually, let me see here. I'm just going to cut it. I'm going to do Control X. So I didn't see the option to cut it when I right click. So I just use Control X, a keyboard shortcut, to copy it and then delete it. All right, and we're going to create a new cell by clicking this plus sign plus code here, and it's going to add a new cell here, and I'm just going to paste what we cut up there, which was that for loop, instead of me having to rewrite it again. And this time we're going to just play this one cell, or click that button there to see what it prints out, and then we get 2, 3, and 4. All right, so you'll notice that it didn't print out that text up here in this cell. And now if we just run this cell by itself, we can see we just get the text. All right. Now you may say, well, what if I want to run both cells? Well, that's simple. We can just go up here to runtime, and you're going to click run all. And you can see that it runs all the cells that we have. All right. So now we're done with this second cell for now. So I'm going to click on the cell and then go to these 3 dots and click on it and delete the cell. Okay. Now that we're kind of familiar with this setup, let's go ahead and get started with our program to predict the price of houses in Boston using machine learning. Okay, first thing we're going to do is import our dependencies. So we're going to import pandas as PD. We're going to import numpy as np, and from sklearn, we're going to import linear underscore model. Now, sklearn is a machine learning library for Python, and the linear model will contain the linear regression model that we're going to use. And linear regression is a linear approach to modeling the relationship between a scalar response, which is the dependent variable, and one or more explanatory variables, which is our independent variables. All right. And I'm using this model because it's simple to implement and is used to predict numeric values. So like the prices of houses, that would be a numeric value. But one of the problems with it is that it's prone to overfitting, meaning that it's really good at predicting the training data, but may not be good at generalizing. So if we give it other data, it may be completely off. And another problem with it is that it cannot be used when the relation between independent and dependent variable are nonlinear. Okay. All right, so let's go ahead and move on. I want to use a function called train test split. So we can get that from sklearn. So we say from sklearn, we're going to import, from sklearn dot model selection is where we get it from. We're going to import the function train underscore test underscore split. All right, and this is a function used to split our data into training and testing sets. And then I'm going to just run our cell. And you'll see, of course, nothing prints down here. But more importantly, we don't get any errors. So I can show you some error messages. I'm sure that we'll see some in this video. But let's say I misspelled this here. I'm going to just run this cell. And you can see that we get a few error messages here. Okay, and the error message says cannot import name train test split. So of course we misspelled it. It needs to be a T there. Let's run the cell again and we're good to go. All right, so I think that's good for our dependencies. Let's add a new cell. All right, so in this cell we were going to load the Boston housing data set. And we can do that from sklearn dot datasets. And let's print it as well. So, and print it. All right, so we're going to have another library we're going to use another library. Actually, it's going to be sklearn's datasets library. So from sklearn dot datasets, we're going to import load underscore Boston. All right, and so I'm going to create a variable called Boston and set it equal to load underscore Boston function, which we got from importing load Boston. And this, of course, will give us a dictionary-like object and stored into our variable Boston. All right, let's take a look at that data. So we're going to print Boston, just so you can kind of see what that dictionary-like object looks like. And I'm going to run the cell by itself. Now, what you can see, we have something called data here, and then we have all of this data. This is going to be our X values or our independent variables or explanatory variables, whatever you want to call it. And then we have feature names. So this will be the names of our column, or columns actually, because there's more than one. And then we have a description here. And let's see, I'm missing the target. Oh, there we go. Okay, I'm sorry. So all of this here is our data, and here's our target. So our target starts here, and this data right here is also our data as well, but this is our Y value. This is the dependent variable, and I highlighted the wrong part before. All of this here is the data for our independent variables or explanatory variables. Okay. But either way, it looks really messy and it's really hard to see. So I'm going to just X out of that. Let's clean it up. So we're going to have another cell, and we're going to transform the data set into a data frame. So I'm going to put that in comments here. Transform the data set into a data frame. And you'll notice that I'm commenting each of these cells. That's so that it's easily readable for me when I look back at this, and also so it's easily readable for other people. You may be working with some with a group of programmers and they need to work on your code. And this is really helpful to people when they're working on code, including yourself, because you might go back 5 years from now, have to work on this code and change something. So it's very useful to comment your code. All right, so what we saw in the dictionary like object, we saw data, right? Something called data. I'm going to put this in comments as well. So we'll say data. And data, I told you guys, was the data we want, or the independent variable, z with a s. And that's also known as our x values. Okay. We also saw feature names. It was feature underscore names. And like I said, this is the column names of the data. We also had the target, and that's the target variable, or the price of the houses, or we can also call it the dependent variable, and that's also known as the y value. Okay, so there's many different names that you're going to hear interchangeably. All right, so let's make a data frame. So I'm going to create a variable. I'm going to call it df for data frame underscore x. So x df underscore x will hold the x values of our data. So we're going to use pandas. So all I have to do is say pd dot data frame Boston dot data comma columns equal Boston dot feature underscore names. All right. And if you're wondering, how did I know, to look for data and feature names and target, things like that, I looked at the documentation on the sklearn website to kind of see how to extract this data and make it look a little bit better. All right, so now I'm going to create another variable. We're going to call it df underscore y. So df of course stands for data frame, and this time it's going to hold our y value. And so we basically do the same thing, pd dot data frame, and then we're going to just put in the target, so Boston dot target. Okay. And the reason why I'm doing the Boston dot is because, again, Boston is a dictionary like object, so it is an object. So where we have data, obviously we're going to use this. Some people call it the dot notation. All right. So that's why I have Boston dot data, and then I have Boston dot feature names and Boston dot target. All right, let's run this cell and make sure we didn't make any mistakes. All right, so I just ran it. It looks like it's pretty good. All right, so let's open up a new cell, and let's get some statistics from our data set. So we're going to get some statistics from the data set, like the count and the mean. Now to do that, we can just say df underscore x dot describe, and then left parentheses, right parentheses, and let's run this cell. And there we go. So we can see count, we can see mean, we can see standard deviation, we can see minimum, we can see maximum. So that's pretty cool if we want to do some analysis on the data. I'm just going to exit out of here. I just kind of want to show that to you guys if you did want to take a closer look at the data. All right, so let's go ahead and create a new cell. All right, and here we're going to initialize our linear regression model. So let's go ahead and put that in the comments, and I'm going to say initialize the linear regression model. Okay, so we're going to just create a new variable called reg and set it equal to linear underscore model dot linear regression. Okay, and I think that's right. So let's go ahead and run this cell. All right, and we get no issues, so like that's pretty good. Let's create a new cell here. And let's split the data into 67% training and 33% testing data. All right, and so we're going to use that train test split function that I talked about earlier up here to do this. All right, so we're just going to type xtrain, comma, x underscore test, comma, y underscore train, comma, y underscore test. And we're going to set it equal to that function, train underscore test underscore split. And we're going to input our x values. So df underscore x. And then we're going to put in our y value. So df underscore y. And then we need to put in the test size. Well, we want the test size to be 33%. So we just do 0.33. And then we need a random state. And I'm going to set it equal to 42. We can set this number to anything we want to. It's just a seed for the random number generator. And actually, it does a little bit more. If you keep the same number, it keeps it in the same order. So you can read up a little bit more about that. But let me make sure I comment this code as well so that we know what we're doing. So we split the data into 67% training and 33% testing data. All right, and let's go ahead and run this. Okay, no errors. So let's go ahead and add a new cell. And let's train the model with our training data. Okay, so to do that, we're going to use a function called fit. So fit is just another way of saying train. So we just say reg, and I probably should have mentioned reg stands for regression. That's the reason why I chose that variable name. So we're going to say reg dot fit, and we need to tell it what data to train on. So x underscore train and y underscore train. Okay, so let's go ahead and run this. All right, so this is not an error message, and that's good. So we'll go ahead and X out of that. So that's good. Let's go ahead and create a new cell. Oh, I have to click in this cell here. You're going to click here for the new cell. And we're going to print the coefficients, also sometimes called weights, for each column or feature of our model. And so let me write that as well. Print the coefficients slash weights, and I may be spelling coefficients incorrectly, but oh well, for each feature slash column of our model. All right. Yeah, I think coefficients is with 2 F's. All right, so how to do that? We just say print reg.coef underscore. And let's run this. All right, and so what we can see is that we get back a bunch of coefficients for our linear model. Okay, so let's exit this. These are our coefficients. If you're not really sure what I mean by coefficients, let's look at a simple function really quick. So let's say I had a function f of x, and I set it equal to mx plus b. Of course, this is equal to y. So we have our dependent variable y, and we have our independent variable x, and then we have our function. This is our linear function. Now here in B is our y-intercept right there. And of course, x we were given from our parameter. Now m, in this case, is the coefficient. And so that's what we're seeing is a bunch of coefficients. So we're seeing something like f of x, comma, I'm just going to throw another letter in there, a. So it's like mx plus, we'll say na. Not na is not good. I'm just going to create another letter. So we say dA. There we go. Plus b. So x and a are input parameters, and d and m would be our coefficients. Okay, so I'm just going to get rid of that. Let's go ahead and create a new cell. Okay, and now let's print our predictions on our test data. So print the predictions on our test data. Okay, so I'm going to create a new variable called y_pred for y predictions and set it equal to reg.predict. And we're going to make these predictions on our testing data set. So we're going to put in the parameter x_test. And also I want to print this to the screen. So we're going to print y_pred. And let's go ahead and run this. All right, so now we can see our predictions here for our y value. Let's exit out of that. Let's go ahead and create a new cell. So what I just did was I moved the cell up on accident by clicking this up arrow. Let's go ahead and move it back down. That was an accident. And we're going to create a new cell. All right. So let's take a look at what the actual values look like. So we're going to print the actual values. So all I have to do is just say print underscore y underscore test. This will be the actual values. And let's run this. Okay, now this column here is what the actual value is for our data. And let's run this other one up here. And we can see that for the first row, our model actually guessed that the value was 28.53 and the actual value was 23.6, so it's about 5 off. Let's see here. Next, we were expecting 32. Let's see what our model predicted. 32, it got 36, so that's pretty close. So far it's looking like our model is doing pretty well. Let's see, our model predicted 15.63. Let's see what the actual value is. The actual value is 13.6, so it's only about, 2 off. And let's check one more. So we're expecting 22.8. Let's see what our model guessed. So our model got 25.5. So that's still pretty close. So how do we know how good our model's doing? Well, we can use different metrics to check the performance and accuracy of our model. So one metric I'm going to use is called the mean squared error. So that's MSE for short. So we're going to click on code. And I'm going to say check the model performance / accuracy using mean squared error, or MSE. So we can print it using NumPy. So we can say np.mean, and within there we can have our y predictions, y_pred, minus the actual values, so that's y_test, and then we're just going to put it to the power of 2. So we're squaring it. Let's run this. And so we get 20.724023, which is pretty good. because if you'd imagine that our predictions were the exact same as the actual values, then this statement here, ypred minus ytest, would give us 0 if they matched every single time, if the values were the same. And so we really want to get as close to 0 as possible, and 20 is pretty good. So that's just using NumPy. We can also use sklearn metrics to kind of see how our model's doing. So let's do a new cell. Here I'm going to say basically the same thing. I'm just going to copy this up there using Control-C, a keyboard shortcut. And I'm going to paste it here with Control-V, another keyboard shortcut. And this time we're going to put and sklearn.metrics. Okay, so we need to import those metrics. So from sklearn.metrics, we're going to import mean underscore squared underscore error. All right, and so now we just print mean underscore squared underscore error, and we're going to input our y-test, the actual values, and then we're going to put in our predicted values, so which is ypred. All right, and let's run this, and you can see that we get basically the same number, but a few more digits past the 3 here. So we get 20.72402.3, and then 437.339.717. Okay, now of course you don't want to usually just go with one metric to kind of test your model, but this right here is pretty easy to implement and kind of easy to understand. It's essentially something called the loss function, but there's other metrics as well that you can use, like r-squared, and you can check the performance of your model. All right, so last but not least, I'm going to zoom out here, because now you may want to save your program that we have here. So you just click on File, and you can see here you could download it as a Python notebook, or you can download it just as a simple Python file. So that's pretty cool. And I noticed that we didn't really run all the cells at one time, so let's go ahead and do that now. We're going to click on Runtime. I'm going to click Run All. Let's zoom in a little bit more. All right, so Runtime, Run All. And now it's running all of the cells. And so we can see our predictions there. And we can see the actual values being printed out there. And that's it. All right. So thank you guys. I hope you enjoyed this video. Please leave any questions you have in the comment section. I will put the code up on my GitHub and a link to that in the description below, so you guys can download this program for yourself and play with it. Be sure to leave likes and comments, and if you found this video helpful, maybe others will as well, so please share it. And as always guys, thank you for watching, and I'll see you all in the next video.